Hey guys, welcome back. In this video, we'll understand the basics of a RAG application, what are components involved in a RAG application, how we can implement a simple RAG application to understand the components involved in it. Come, let's go into the video. And if you look at the diagram right here, it explains the source where the data is coming from and how the data is split. So let's say you have a PDF where you have a lot of data. We will split them into chunks. I'm going to use a fixed length chunking. I'll explain you what it is and how it's being done. And once the text is chunked further, we will embed the chunk. So it is called indexing or embedding. So the embedding model that we are going to use is also from Ollama, and then embed the chunks. And all these embedded chunks will be stored into our vector store. We're going to use a ChromaDB here. There are multiple vector stores available, so we'll see future videos. So in this video, I'm going to use ChromaDB to explain you how to store the embedded chunks into the vector store. So once this is stored, so when a user is querying from the PDF that you have, and what will happen is the query will be embedded with the same embedding model that we use to embed the text chunks that we have in our source. So using that, we're going to query the similar documents from the vector store. So it's called a similarity search that we are going to make, and that will retrieve. So if you look at here, this diagram explains the query plus similar documents, and that will be fed into the LLM, and the LLM will respond back to the user with the response. And I also explained you something with the chunking. So we are going to chunk the data, so the text from the PDF into fixed length of text. Okay, so let's say here I've explained, say you have a text. Okay, so this is a paragraph I have. I'm saying I want to split the text that I have into 100 in the length. In this case, I'm going to use a recursive character text splitter. I'll explain you while implementing how this is being imported and how this is being it'll work. Why we are splitting into multiple chunks? The relevant data, you cannot just go ahead and look at the whole document, right? So if you split everything and then store it into a vector store, the similarity search can be applied on the index. So let's say you are searching, you're storing something into your DB and it has an ID, right? So if you are giving the ID, it will be easy for the database to query the index. So that's what's going to happen here. So the index is nothing but the whole text chunk that you have. So whatever the query that you're passing in, and if any similarity to the query that you are provided that exists in your vector store, then that is going to be retrieved as the similar documents and then passed on to the LLM. And that one, the LLM is going to respond back. It's going to give you the generation, right? So the part that we are looking at here is the retrieval from the vector store with the similar documents, and then it's going to provide to the LLM, and LLM is going to work as the generation. There are so many components involved in RAG. There are data sources in this case. So here you can see the data source might be from a PDF, can be from web, can be a video or audio or some unstructured data, whatever it may be. And then we are ingesting the data. So data ingestion is also a part of it. So, and also we have data processing, and data processing is something, but you clean the data into a cleaner one, right? So you don't want all the data to be loaded. Let's say you have a PDF that has maybe a header which it says Adobe PDF. So you don't want that. So you want the content to be chunked. And another is the embedding model. That's one of the component itself, because that is the main component to embed each chunks that you are extracting. And then the vector store, and nothing but it's such a DB which will store in a vector format. So vectors are nothing but you will get in the kind of numbers. Let's consider that is a binary format, right? And then and whatever text you have will be converted into vectors, zeros and ones, and then it will be stored into the vector store. And then we will have a retriever which will retrieve the documents, similar documents, which will apply the similarity search and then get the data. Okay, and we have the LLM. It's a large language model, and we are going to use Ollama here. You can use anything, but I'm having Ollama running in my machine. So if you look at here, the Ollama is already running in my machine, so I don't have to get an open API key and then hit the open API and that's that. So I'm just going to explain you with the Ollama itself. And we also have response generation, which already done by LLM, and you can also customize how you want the response to be, right? And there are optional steps which will involve something like ranker, re-ranker, so that will re-rank the responses that the LLM is providing, and it can be stored, persisted into the DB, and then further whenever you request the same data, and it can look at the rank, and then it can send the similar, most relevant document depending upon the feedback that you provide. With that, I think it explains all. So if you have any questions on the rank basics, you can put it on the comment. I'm ready to explain. Let's move on to the implementation. For this implementation, I've already created simple Python project with the virtual environment, and it has a PDF which I'm going to read. So this is going to be our source. We are going to query from this data. Moving on, these are the requirement that you need. You can just I'll give you this code. You can install this and then you can start the project. I have the Jupyter notebook right here. So the first step that you want to do is we are going to first implement the LLM, so which is right here. I'm going to use Ollama as I said previously. So I have Llama 2B, and then the model provider is Ollama, and I'm initializing this model, and I'll get this model and store it in this model. I'm executing this. So moving on. Yeah. So it should create and initiate the model. So I'm using Lang Chain. Let me go over the next step. So next step is going to be loading the document. So what I'm going to do is I'm going to load the document. Now I'm going to use the document loaders from the Lang community and load it. So I'm going to use PyPDF loader, I think, which I already have it here. See, if you look at here, I already have the dependency. So the PyPDF loader will load the PDF itself into a loader, and I'm going to use .load to load the document here. Executing this, I'll get the document once this is done. So going back to the diagram, now we have loaded our PDF and also our LLM model. Okay, so these two are ready. So now I'm going to split the data inside the PDF into text chunks. I told I'm going to use recursive text character splitter. So the character text splitter, I'm going to use that. So that's going to come from the Lang Chain text splitters. So it's a package, so that's going to provide it. So I already have it here. So Lang Chain text splitters. So you can just include that. So I'm going to say, okay, going here. So this is the code that is needed to split the document into smaller chunks. So this whole document that you see here, it's going to be split into 100 characters length. So whatever it is, it's 100, let's say it is here, then it will just split that, and then it will give an overlap. Then whenever that it is cutting over any of the word, then it's going to give an overlap. We will look at that now. Okay, so now if you look at here, we have loaded the text splitter, and then with the recursive split characters text splitter, we have given a chunk size of 100 and then chunk overlap of 30. Okay, and that is all it is. And once this is created, you have the text splitter, and that has a method split documents. So you can just provide the document that you want. So we have already loaded the document here, and I'm just providing that as a input, and that's gonna give you the chunks. So I'll just execute this, followed by I'll show you the chunks. Okay, so let's print the top 5 chunks. Okay, so if you look at here, it has already chunked all the data that you see on the PDF. It has splitted like this. So if you look at this line, it has splitted heritage into both the chunks. So this is the overlap that we have right now. Okay. Okay, so moving on to the next one. So we have already chunked it. So we are at this part now in the chunking. So we have created the chunks. Okay. So now we need an embedding model. So I'm going to use nomic embed text model from Ollama itself. So that you can refer to Ollama's website to know about the installation and also about how to, what are embedding models available, what are large language model available, and what are the parameters that you can execute in your machine, right? So if you become a model that is having huge parameters, you cannot execute in your machine, so it will take a long time. So it's better to pick a smaller model when you're just practicing something. Okay, so that's why I'm using gamma 2b, that's 2 billion parameters, that is low, so that I can execute in my machine. So my machine has a less configuration. So moving on, so we are going to create the embedding model. For that, I'm going to Ollama embeddings. Okay, so I'm saying this embedding is being done from Ollama, so it's Ollama embedding. So LangChain Ollama will provide that, and then I'm passing in the model that I'm gonna use. So if you go to Ollama's website, you will find a lot of embedding models. So I'm gonna use this, okay, because I'm just working on the text, so I'm gonna use this as embedding model. So I'm just creating the embedding model, and then this line will give you the embedded chunks. So if you look at here, embedding models as embed documents of chunks, that chunks that we have created here, I'm just passing in here. So this will give you the embedded chunks. Now the embedding chunks are created. So if you go back to the the diagram, so now we have created the embedding model, and then we passed on all the chunks to the embedding models. We got the embedded chunks. So now it's the next phase. We need to store it into our vector store. So we are going to use ChromaDB. That is our vector store that we are going to use here. Okay, so I'll put this. If you look at here, I have given it as I've imported the ChromaDB, and I've given a collection name. Okay, collection name, if you worked with MongoDB and other stuff, so collection name is something like a table name in a relational DB. So it's then in ChromaDB, so we're giving a collection name of this, and then embedding function. So the embedding function, we are providing it as the embedding model that we have. Okay, so whatever the embedding model that we have created, so I'm just passing in right here, and then I'm going to create it into a directory named this. Okay, I'll just remove one from here. I'll just execute this. So this will create a directory in your file explorer. So if you look at here in the project directory, you should see chroma _langchain_db. So if you look at here, yeah, that's your chroma SQLite DB. Okay, so that's it, and let me move on. So now we have created the vector store. Let's add the data into the vector store. Okay, I'm gonna add a markdown. I forgot, right? So here the vector store itself is provided with the embedding model. So at this step right here, you don't have to do it. Okay, this one you don't have to do, because if you provide the chunks to the vector store itself is going to convert into the embedding models and then store it. To explain you, as per the document, I've just created this. Okay, so now the vector DB is equipped with the embedding model, and that is capable of converting into the embedding and then store it into the DB itself. So I'm just passing in the chunks that we have created, and I'm just calling the add document method from the vector store. This is going to add it. So this is going to create the vector. So if you look at here, these are all the index that it has created. Okay, so if you look at here, so this is all of the data that is created once you store it into the DB. Okay, so now moving on to the diagram. So we have stored all the data into the vector store. So at this point you are good. Now it's the matter of executing the query and then getting back the response. I'm gonna use Retrieval QA, a query and answer. There are many packages that are available that you can make use of, but this is something is quick and dirty solution that I found. So here I'm importing the Retrieval QA. So this is the Lang Chain query and answer package. So here what I'm going to do is I'm creating a query and answer chain, and then this chain will be created from this dot from chain type, and I'm going to provide the model. Here this model is nothing but the model that we have created here. Okay, this is the Gamma 2B model which is running in my local machine. So I'm providing that, and with that model I'm like the retriever is going to be the vector store. So this is going to be a source. So it's gonna provide the top 3 relevant chunks back to the model. So if you look at here, along with the query, we have picked the similar documents. So these similar documents will be fetched with this command, the vector store as retriever search krs k3. This is going to give you the relevant 3 chunks back to the LLM model. Okay, and then optionally we can return the source. That's what I'm doing here. So just execute this and we can invoke this chain now. Okay, so what I'm going to do is I'm going to say if you look at the PDF, there is something with respect to Himalayas. What all Himalayas comprise? Okay, so this is going to be my query, and I'm invoking this Lang chain, the query and answer chain, and with the query. Okay, and this is going to give me the result back. So let me execute this. So once you do this, it's going to make the complete process that we see in this. It's going to give the query, embed the query, and then similarity search, get the similar documents, pass it on to the LLM, and LLM is going to respond to you back. Okay, so this is what is going to happen now. My machine is very slow because I don't have that great graphics card. So if you look at here, so this is coming from the PDF itself. Okay, so let me go to the PDF and search for that. So if you see here, Himalayas comprises of 3 parallel ranges respected large altiers and valleys. So this is the chunk. It's more relevant to the query that we have hashed for. So that's why it is returning the data back to us. Okay, with this I think I've covered the basics of all the RAG components. There are much more that we can cover, but I think I'll just stop here, and then we'll see in the next video implementing a small user interface. With using that interface, let's create a backend application instead of us putting everything in Jupyter Notebook. Create a backend application, and then the UI, we'll just do a local chat GPT kind of a thing, and then chat with the model that we have, and then our private data sources. Okay, hope you like this video. If you like this video, don't forget to subscribe and like. Do comment your questions. Thanks for watching.